It's August 16th, 2020, and a cluster of thunderstorms emerges off the west coast of Africa. Satellites track this disorganized cluster of showers and thunderstorms as it moves over the warm waters of the Atlantic. On August 20th, a weak area of low pressure is detected. Now we're looking at a tropical depression. The next day, winds circulating around the center increase to 39 miles per hour, and Tropical Storm Laura is born. The storm maintains its strength as it moves through the Caribbean. Then, as it moves into the Gulf of Mexico, it gets stronger rapidly. By the 25th, it's a Cat 1 hurricane with winds of 75 miles an hour. Laura would jump past Cat 2 and Cat 3 to reach Category 4 hurricane status later that same day, eventually peaking with max winds sustained at 150 miles per hour. The storm just misses Houston to the east and devastates Lake Charles on the evening of August 26, 2020. For a storm like that to come so close to Houston-Galveston, let alone a strong Category 4 hurricane, it takes a large number of things in the atmosphere to go just right. Let's back it up, start from the beginning, and take a closer look at how a storm like that is born. Hurricane season staying weather smart.
There are a lot of factors that go into the formation of a hurricane.
Everything from water temperature near the equator to dust from Africa impacts the storms we see here in Houston.
And those storms can pack a punch.
And while we are no stranger to the destructive power of hurricanes, the science can seem overwhelming.
And that's why we're here, to keep you weather smart, starting with what allows these hurricanes to form in the first place.
As we look into how hurricanes form, we need to first look at the global forces that can determine whether we'll see a busy or quiet hurricane season. We're talking about 3 ocean patterns that can each act as an on or off switch that can help create or kill a brewing storm. First, the El Niño Southern Oscillation's 2 phases, El Niño and La Niña. Both of these affect sea surface temperatures in the Pacific Ocean, which then alters wind strength blowing into the Atlantic. During El Niño years, the sea surface temperatures near the equator are generally warmer than average. That creates stronger winds in the Atlantic, which can then shear the tops of hurricanes, making it harder for them to form and strengthen. On the other hand, during La Niña years, the water is cooler, which means lighter winds, allowing hurricanes to grow stronger. Next, we head to the North Atlantic Oscillation. This is a weather phenomenon that controls the strength and direction of westerly winds. At play here is the low atmospheric pressure near Iceland and the high pressure near the Azores Islands. When the difference between them is lower than average, the winds are weaker, meaning hurricanes are more likely to form. When the 2 pressure systems are more intense than average, wind conditions increase, making it harder for hurricanes to form. Now let's head further south and look at the Atlantic meridional mode, which determines sea surface temperatures, either warmer or cooler than average. When the area north of the equator is warmer than average, that gives hurricanes the energy they need to grow and intensify. When the same area is cooler, hurricanes are less likely to form. So bottom line, hurricanes love warm water to give them energy and light winds that won't interfere with their development. So when these 3 patterns work together to give them those conditions, we can expect a busy hurricane season. But cooler water in the Atlantic and strong winds lead to weaker storms and a quiet season. So what do conditions look like right now? Well, we're currently seeing sea surface temperatures running 3 to 5 degrees above average and trending in a La Niña pattern for the 3rd year in a row, which could lead to an earlier Cape Verde season and can lead to more storm formation. A few other things to keep in mind. Have you heard of the Saharan air layer? Well, it is a dry air mass made up of dust, dirt, and sand that originates over the Saharan desert in Africa. It can be as high as 20,000 feet. Remember, the easterly trade winds can transport this dust across the Atlantic Ocean and can make its way right up to Texas to, of course, irritate our allergies. However, when talking hurricanes or possible storm formation, it can limit the strength of a cyclone. Basically, it shears itself apart. Dust transports itself during the summer months, which is the same as hurricane season, so it can limit storm activity across the Atlantic.
Once a hurricane does form, you've noticed they spin counterclockwise like a record. That has everything to do with something called the Coriolis Effect. And that has everything to do with the fact that our planet Earth is a huge rotating sphere. That means objects near the center or equator of the planet are moving much faster than objects near the top or North Pole. Now, throw a ball from the equator toward the north. Because the ball maintains its higher velocity, as the planet's rotational velocity slows underneath it, the ball appears to bend off to the right. Same thing for a ball moving north to south. Earth's velocity increases under the moving ball, and it appears to bend off to the right. The same goes for moving air. When low pressure forms, that low wants to pull air toward it in a straight line. But the Coriolis force, it wants to bend that air off to the right. The result, the air spins around the center of low pressure in a counterclockwise direction. And that is why hurricanes spin in the first place, because of the Coriolis effect.
When we discuss tropical systems and their movement across the Atlantic basin, we have to discuss one large semi-permanent atmospheric feature that plays a big role in where these systems go and also their intensity as they make their journey across the Atlantic Ocean. For that, we go out to the island nation of Bermuda, where we find this very large semi-permanent air mass called the Bermuda High. It borrows its name from the island nation it's typically found over. As we go through the next several scenarios, we'll break down where these systems could potentially go as they make their journey westward. With scenario 1, we have a system that's moving in towards the east coast. It's going to be coming out of the Atlantic Ocean, and it's going to make its way through portions of the Bahama Islands, then head up towards the east coast. As it does that, it could see states like Georgia, the Carolinas, and even the Northeast potentially impacted by either a direct landfall or maybe just a glancing blow. Now let's discuss scenario 2, which allows the system, this Bermuda High, to be stretched out in more of an egg-like shape. As it does that, it really moves towards the east coast, covering several eastern United States. As we watch this tropical system make its journey westward, it will go over the U.S. Virgin Islands, the island nations of Haiti, Dominican Republic, Cuba, and even towards the Bahamas. It could also even go right through portions of the southern state of Florida. After that, if it survives its journey, it could go in towards the northeastern section of the Gulf of Mexico. We could see states like Mississippi, Alabama, and the Florida Panhandle impacted by a direct landfall from a tropical depression, a storm, or even a hurricane. Now, with scenario 3, we discuss how this tropical system right here could potentially get steered into the Gulf of Mexico because the Bermuda High is much, much bigger now that it stretches its legs all across portions of the East Coast and even as far southeast as the West Mississippi River Valley area. Once we watch this system make its way through the Caribbean Sea, it can impact several nations along the way, out towards Haiti, the Dominican Republic area, through Cuba. Then after that, if it survives its long journey, it will get into the Gulf of Mexico. As it gets there, it could possibly go through several different paths, taking it to Mexico, towards Louisiana, Mississippi, but also taking it right here. Unfortunately, portions of Texas, and that definitely includes us right here in the Houston metro area. That's why we must pay attention to the entire tropic season to see where the Bermuda high pressure is, because that may determine where a tropical system is steered and if it's being sent our way.
Satellites. They give us the ability to look down on our planet and see things from an otherworldly perspective. From the first crude televised satellite image in 1960 to today's high-resolution images from cameras hovering thousands of miles above our planet. It's the ability to look down on the oceans that has had the greatest impact on tropical meteorology in the past 100 years. This bird's eye view gives us information about developing storm structure, intensity, the environment it's moving into, changes in sea surface temperature, all from a very safe distance. Now, that being said, there is no replacing piercing into the center of an approaching storm to gather first-hand data. So once a storm like this gets into range, the hurricane hunters fly. When we come back, we fly into the eye of the storm. One of the important tools we use in determining a storm's strength and movement is those amazing hurricane hunters that literally fly right into the middle of a storm. How do they do that? And what are they doing while inside the storm? It's all about the science. Hurricane hunters provide a lot of information about a storm, but how are they even getting inside? They're flying a plane called a WC-130J, like this one. It's a modified version of the C-130 plane that you might see dropping that red stuff on fires out west. These planes are tough. They can fly for longer periods of time and they can take a beating. These airborne science missions are run by the 53rd Weather Reconnaissance Squadron, which has been flying in a storm since 1944. In the cargo section of the plane, there are two different pallets of computer systems that take all the data from the sensors on the plane's exterior to help determine what's going on inside the storm. The hunters also drop these parachute-type sensors called SONs, which float through the storm, relaying info about a storm's pressure, wind speed, and direction. That information all comes together, gets processed, and is then shared through the National Hurricane Center for us to share with all of you. The hurricane hunters aren't the only ones flying in and around a storm. The National Oceanic and Atmospheric Administration also has a couple planes flying into and around a hurricane, dropping measurement instruments right into the storm.
Those planes also give us important information on the dirty side of a hurricane. The dirty side of a storm refers to the area of a hurricane or tropical system where you'll find the highest winds, highest storm surge, and the greatest tornado threat. So what side of the storm is that? Well, generally, it's the northeast side of the storm, or more simply put, the right side of the storm. But it also depends on which direction the storm is moving. If it's traveling in a northern direction, the dirty side will be more on the direct right-hand or eastern side. If the storm is traveling in a more western direction, the dirty side will be more on top of it, or the northern side. So what makes it so dirty? It's all about the wind direction, and a little math. For example, if a storm is moving north at 30 miles per hour and has a wind speed of 100 miles an hour, then the storm will produce winds of 130 miles per hour on the right, dirty side. While on the left side, winds move in the opposite direction of the storm's movement, so they'll be slower at 70 miles per hour. It's important to remember, though, as a storm grows stronger, every side becomes dangerous, especially the side that triggers storm surge.
Storm surge is by far the deadliest part of a hurricane, when wind from a storm literally pushes water in from the Gulf inland. All along the coast, you'll see markers like this one showing you just how high water from previous storms have gotten. Now let me show you just how dangerous storm surge can be. 1 to 3 feet of water can knock you off your feet and stall your car. When the water gets above 3 feet, it can float your car away. If you're still home when the water gets up to 6 feet, you have to seek higher ground, like the second floor or the roof. A 12-foot storm surge will fill an entire first floor, and 15 feet covers a typical one-story home completely. Now, for what 20 feet can do. 20 feet is downright catastrophic, and it happened. When Hurricane Ike hit Galveston in 2008, the Bolivar Peninsula was considered ground zero, where entire neighborhoods were washed away, as you can see from these before and after photos from the U.S. Geological Survey. But the deadliest and most destructive hurricane of all time was the Category 4 storm that hit Galveston on September 8th in 1900. A 15-foot storm surge covered the entire island. It destroyed about 7,000 buildings and killed an estimated 8,000 people. Of course, hurricane forecasting has improved immensely over the years since then to give people a much better heads up. Storm surge. Well, the primary threat is right along the immediate coastline, but as a hurricane moves inland, it then becomes about the wind.
When it comes to tropical systems, it's the wind speed that determines how a storm is rated or categorized. Tropical storm force winds are on the lower end, but still need to be taken seriously. They have sustained winds of 50 to 60 miles per hour, with gusts even up to 80. That's enough to knock anything around your yard, anything that's not tied down, and cause a good amount of flooding depending on how slowly the storm is moving. Once you get to 74 miles per hour, we're dealing with a Category 1 hurricane like Hannah that hit Corpus Christi in July of 2020. Now at this point, homes can start to see damage to the roof, with loose shingles starting to fly off, but for the most part the damage is minimal. But this can also take down small trees and branches, which could bring down power lines, causing widespread outages. Now at 96 miles per hour, we're dealing with a Category 2 storm, just like Sally, that hit Alabama back in 2020. When the wind gets this intense, more objects start to get thrown around, bigger trees are coming down, and even more branches are getting tossed down the street, and projectiles are getting tossed right through your windows. Now you might see some of your vinyl siding even start to peel away. And if the wind is able to get inside of your home, it can start to rip parts of your roof off. Now once we get to 111 miles per hour, we're dealing with a major Category 3 hurricane. Think back to Zeta hitting Louisiana a couple of years ago. This is strong enough to cause extensive damage, and mobile homes are going to have a really tough time surviving this. And when the wind is strong enough to actually blow your door in wide open, that's when you can get wind starting to lift up your roof at weak points. At 130 miles per hour, that marks a Category 4 hurricane. This was Harvey hitting Rockport near Corpus Christi in 2017. The wind alone from this storm can smash windows, causing extensive damage inside, with most shingles and even part of your roof getting blown away. Most trees and power lines are getting knocked down, with power outages everywhere. And that could cause a serious issue for access in and out for emergency crews, with road closures due to all of that debris. And finally, once a storm hits sustained winds of 157 miles per hour, we're talking about a catastrophic Category 5 hurricane. And this is the highest rank a storm can get. Remember how Hurricane Dorian just devastated the Bahamas in 2019? If your home has no roof, the walls can collapse at this point, flattening your home and leaving an area uninhabitable for weeks or months. Now, of course, this is just the damage from wind to your home and the power lines. The rain and flooding can also wash away roads and bridges like we saw here in Houston during Harvey. Now, to put things into perspective, the most destructive winds are typically at the center of the storm, around the eye, which is a very small part of the hurricane. However, because these storms are so large, those damaging winds can stretch out for miles in all directions, and depending on how slowly the storm is moving, can produce punishing winds for hours. Now, we've thrown a lot of information at you, and we know that you have questions. So we're getting you some of those answers next.
All right, we've been throwing a ton of information at you about how to prepare for hurricane season, what these storms mean for you and your family, but we know you've got questions, so let's get you some answers.
I'm Jaylee Sam Nonvat, and this is Biscuit Sam Nonvat, and we wanted to know what causes hurricane season.
Well, the recipe for a hurricane requires very specific ingredients that are in season between June 1st and the end of November. The first thing, abundant sunshine. That warms up our oceans, allowing for sea surface temperatures to become the fuel for hurricanes. Second ingredient is going to be a seedling, usually a tropical wave off the west coast of Africa, but it could come from the US or South America. Now, those two ingredients need to marinate. They need to simmer, and in order to do so, they can't be disrupted by the wind. That is ingredient number 3, calm upper level winds.
My name is Erica Silva, and my question is, why is the eye of a hurricane calm?
Well, that's a great question. The center of a hurricane is calm because the air there is forced to sink, something we call subsidence. And when that occurs, you can get calm winds. And even the skies will clear out and you can see the sunshine and blue skies or the stars at night. Now, just a few miles away, you're going to find the strongest part of the storm, the eye wall, that consists of the strongest winds.
My name is Charles, and how does the temperature near the ocean affect the weather here?
Okay, the water temperature in the ocean absolutely impacts the weather that we see here. So during hurricane season, or talking tropical weather, storms need warm water temperatures. And basically you can think of them sucking up that heat, just like a straw would do with liquid. Now, water temperatures also impacts the potential for fog or nice weather days as well.
Hi, my name is April Valdivia, and my question is, why do we get hail on a warm day?
That's a great question. We actually have another question about hail, so let's make this a two-parter.
My name is Robbie Lopez, and my question is, how do hailstones grow bigger?
So even on a hot summer day, when thunderstorms develop, the air above is below freezing. And so what happens within these thunderstorms is you get updrafts and downdrafts. In those updrafts, you get the water droplets within the thunderstorms getting lifted above that point where it's below freezing. And when that happens, ice forms. Well, if the updrafts are strong enough, it can suspend those ice particles in the air, and eventually they grow into hailstones. And if the updrafts are strong enough, those hailstones can grow to be huge, and sometimes upwards of grapefruit size, which can be very dangerous.
If you're still curious about the hurricane season, we're giving you a lot of information at your fingertips with our 2022 Hurricane Preparedness Guide. It's easy to get. Just download it from khou.com/hurricane or text the word weather to 713-526-1111, and we'll text you back a link to the guide and other updates on weather. Stick around for this year's hurricane forecast. So now you know the science behind how hurricanes form and whether we'll have a busy or quiet hurricane season.
Based on the conditions we're seeing right now, we're forecasting an above average season. 14 to 21 named storms, 6 to 10 of those being hurricanes, and 3 to 6 of those having major status. That's a Category 3 or higher.
The National Hurricane Center always has 21 names on the list, and that list is recycled every 6 years. Now, the only time that list will change is if a storm is so devastating that it's retired and then replaced with a new one. Now, the last time a storm name was retired was Ida last year when it roared ashore in Louisiana as a Category 4 hurricane. It caused widespread flooding and tornadoes across several states.
This year's hurricane names list starts with Alex and ends with Walter. If we use all of the names on the list, like we did with the 30 named storms in 2020, any additional storms will take a name from a supplemental list from the World Meteorological Organization. That list starts with Adria and ends with Will.
Now, of course, the weather can change at any moment, which means we could see more or fewer storms than what's being forecast. That's why, no matter what, it's important for you to stay weather smart.
So we will stand for Houston by standing with you every step of the way, from the beginning of the storm to the end.